Hi, myself Shivakumarswami Ramagirimath. I am from KLE Technological University. Now I am going to explain about the second assignment of Skyfi Lab, that is tall building structures, seismic resistance building. Go to the define, go to the load patterns. Now add the new load, that is seismic load. Choose the load type as seismic. Select IS 1893-2002. Now add new load. Now the seismic load is added. Go to the modify lateral load. So select X and Y direction. So do not select X and Y direction eccentricity. These eccentricities are used in the particular, if the building is in the particular location. For the seismic zone factor, go to the IS 1893-2002. So we are constructing the building in the Bangalore. So Bangalore lies in the blue zone, that is zone 2. Go to the table number 2. So in table number 2, that is clause 6.4.2, the seismic zone factor is 0.1. Go to the software, select seismic zone factor is 0.1. So select site type, that is in chart the soil type is type 2, that is medium soil. So select that soil site type is type 2. So response reduction factor, go to the IS 1893. From table number 7 we got the response reduction factor is 3. Click on OK. Click on OK. Now go to the load combination, check whether all the load combination are there. Yes, click on OK. Go to the analyze, set load cases to run. So in seismic analysis we do not want to run the wind load, so make it as a do not run and click on run. Now the analysis is going on. Yes, the analysis is over. So place the cursor on the element, you will get the displacement values and other values. So now go to the next step, that is design part. Go to the design, select concrete frame design, check view preferences, that is IS 456-2000. Click on OK and start the design check. So it takes a little time. Yeah, now the design part is over. So you zoom on, so you'll get the values, reinforcements values. So right click on any element, you will get the reinforcement values and details, concrete designs. These results are obtained after the design part. Click on OK. Now we are going to the next, that is response spectrum method. For this response spectrum method, go to the define, go to the load patterns, check seismic load whether it is added or no, modify the lateral load. So check whether For this X and Y direction, click on OK, click on OK, go to the define, go to the function, select response spectrum, in choose function type of select IS 1893-2002, add new function. So change the function name as the response spectrum. So zone factor 0.1, soil type 2, click on OK, click on OK, go to the define, go to the load cases. So remove this wind load, add a new case, that is response spectrum. Select response spectrum. So add a load applied. So acceleration u1, that is x direction. Select the response spectrum in the function. Scale factor as we have calculated, that is 163.5. Add another load, that is in the y direction. Select response spectrum. Click on OK, click on OK, go to the analyze, set load cases to run. So in this response reduction factor, we do not want to run the dead load and live load, so select and make it do not run and click on run now. Once the analysis is over, we will get the displacement and shear force bending shear force values. So place the cursor on the any element, you will get the displacement values. Now the next step is to design. Go to the design, concrete frame design, select the start design check, click on OK. So you'll get the detailed report of the building. It is the report obtained after the design. So you'll get the reinforcement values, reinforcement, top bar, shear reinforcement. Now we are going with the second method, that is time history function. Go to the initially unlock the model, go to the define, check the load pattern, that is seismic load is added or not. Go to the seismic, modify the lateral load. So in time history function, the seismic waves is acting only on the x directions, so make sure that only x is selected. Click on OK, click on OK. Now go to the define, add a function, select time history. So choose a function type, that is from file, add new function. So function file, we have to add a function file, that is a time history data. Time history, change the name as the time history. Click on OK. Click on OK. Go to the define, set the load cases. So delete the response spectrum, delete the case, click on OK, add a new case, that is time history. Click on time history, add a load, select the acceleration, select the function as a time history. Scale factor, as we have calculated, it is, since there is only x directions. Click on OK, click on OK, go to the analyze, set load cases to run. So here we do not want to run the dead load and live load, so click on run now. Once the analysis is over, the displacement values are getting, so place the cursor on a building, you will get the displacement values. Now go to the next part, that is design. Go to the concrete, start design check. Now the design part is over. Now the design part is over, so click on any member, you will get the top steel, bottom steel and shear steel reinforcement details. So click on details, you will get the concrete frame design. So these are the data after we are getting after the design part. Click on OK. Now the tall building project is over, the seismic resistance building. So go to the model explorer, click on reports, click on report. So you will get the final report of the building, that is tall building. So this completes the model.